Now, our first speaker is from Gilat, Dubi, the Chief Technology Officer. And Dubi has been working with Gilat R&D team for the past 24 years. He has served in senior positions spanning different fields of expertise, everything from hardware design, FPGA, communications algorithms, RF design, system architecture, and also as an engineer and manager. So over the years, Dubi has been leading innovation within the company, initiating the development of new products. So let me just bring Dubi's slides up. And Dubi, all yours.
Thank you, Paul. So good morning, good afternoon, good evening to everyone. All right, so let's go. We're living through interesting times, for sure. As Paul said, I've been in the industry for it's already 25 years, and it's the most fascinating era. If we look what's happening today, we're going through the NGSO revolution. There's 3GP NTN with the 3GP starting to address satellite. They're very high throughput satellites. We're looking at Viasat 3 at 1 terabit per second satellites, and software defined satellites. Now the ground segment is evolving, supporting this new era. And what we see as the next stage is the migration to cloud. The need is understood by the entire industry. It's coming from the satellite operators, it's coming from companies as ourselves, the vendors, and we have the new players that have joined the industry, which is the public cloud hyperscalers. It's the AWS, Azure, etc. Now, if you think about what we've been coming across in the conferences over the last 2 or 3 years, cloud has been on the table for quite some time. So there have been many presentations, many webinars as such. There've even been some RFPs, RFIs issues. So, everyone's talking the talk. Very few have actually started to walk. There have been some demos over the last year. So it's very clear where we want to be. We want to have a virtual and open system, but it's not really clear how it's going to be achieved. Quick high-level view of what it means going to cloud architecture. So starting at the bottom, so we have the hardware, which is the basic infrastructure. So you have compute, storage, networking devices, and this all has to be virtualized to enable to run on it the next layer, which is the network functions, which are the actual applications. Okay, you have modems, receive, transmit. You have software-related features like QoS, acceleration, encryption, and routing functions. And the layer above that is really the management. So you have SRM, the Satellite Resource Manager, NMS, Network Management System, and the OSS and the BSS. And shifting a little bit to the right, this all has to be orchestrated. Okay, so you have all these different resources, all these different services, and it all has to be orchestrated. Okay, so Gilat recognizes the trend, and we see the value in the transition of the cloud segment to be hardware agnostic and fully virtualized. You can see at the title, the SKYEDGE 4. SKYEDGE 4 is the brand name of our current generation of products, of VSAT networks. And the way we see it, the potential and the value is very high for our customers. So there's high efficiency of CapEx, the OpEx efficiency. Okay, when you have, especially if you're looking in the public cloud, you can lease the resources per need. So let's say different resources needed a day or day at night. So you can lease the resources as they are used. You can streamline the service orchestration across all the multiple domains. Today, it's a bit more complicated. Sometimes you have to have different systems for orchestrating different elements. You have high agility to adopt to changes, okay, because you're more hardware agnostic. So for example, you can migrate to newer platforms. There's a better overall user experience, and the security updates will be more frequent and based on wider exposure to the potential threats, because you're getting service from, especially when you're looking at the public cloud. So our goal is to design a cloud-native solution, but also to be agnostic, because there are different types of clouds. It can be public, it can be private, in some cases it can be hybrid. Okay, so this is I'm going to dive more into the modem, the baseband of the gateway. Okay, because the migration of the network management system and some of the functions running the data center. It's sort of straightforward. But it gets interesting when we start looking at the modems, at what's running in the gateway. So basically, this is the product that we sell today. Okay, it's a chassis. It's a 13U chassis. It supports a full feeder link. Okay, so 5 gigahertz of forward channel, return channel, and it's based on an array of multiple receivers and transmitters. Every receiver and transmitter can process hundreds of megasymbols per second. It's fully managed. You have full redundancy here, and this is what the solution looks like today. When you're ramping up a system, so you have the penalty of buying a full chassis, and maybe you can start off with 1 transmitter and 1 receiver. If you want redundancies, you have a couple of more cards. But basically, you can add cards as you grow. Okay, and as I stated, when the chassis is fully populated, that's all you need to really to light up a full feeder link. So this is today. Okay, now what's around the corner? What's happening in the future? So we're looking really at custom off-the-shelf devices for signal processing. So first of all, there are different technologies that can be considered. There's FPGA. Typically, it seems to be leading with this technology within the data centers is Xilinx. They're GPUs, mainly by NVIDIA, and they're CPU, x86 by Intel. The most common platform is from Xilinx. It's called Alveo. U250 is a popular flavor that's used in the public cloud. And these new processing cards, processing elements, FPGA and GPU are wrapped up with the hyperscale environment. What's needed to work within the public cloud. Now, how do you actually take a decision which of the platforms to use? So there are many different aspects. We've listed a few of the KPIs. So there's cost, both in terms of OPEX and CAPEX, okay, because you don't get the same pricing when you're using the different platforms. The power consumption is different. Okay, so obviously the more hardware-oriented platforms, such as the FPGA going onto GPU and eventually x86. Okay, so the power consumption tends to be better on the FPGA side. There's rack space. Okay, so it depends how dense the solution can be. Performance. Okay, so you can have due to limitations of power consumption and compute power, you can decide, for example, to compromise on the decoding, which would eventually translate to different efficiency of the processing. Okay, so there's performance. There's technology roadmap. Okay, so some platforms, so you have different visibility of what's in the roadmap, and it's different for the different platforms. There's complexity of implementation, and sometimes there can be consideration based on simply available inventory. This may be more common for private cloud. Sorry. And reuse for other applications. Okay, so again, in the private cloud, if you already have a platform and you're using it for other applications, so you can adopt it for signal processing, it has an advantage. You can see below a scheme showing roughly what a future gateway would look like. So you have the processing units. Here we took as an example the U250, which have to be connected digitally to analog to digital converters. And you can see the terminology DIFI, which DIFI stands for Digital IF Interface. And this has to be 100 gigabits per second and maybe even more times, which is eventually connected to sort of like the standard bucket LNB. So I'm going to talk a little bit about this DIFI standard. Even I must say that the companies that are members of the DIFI standard, amongst them Gilat and our subsidiary Wavestream, are very vocal about it, and even yesterday in Via Satellite there was a paper. So I'll go through it very quickly. Basically, the idea is to have a standard. Okay, so if you think about the L-band interface you have today, which is pretty straightforward. Okay, in terms of connectors, in terms of the frequency band, you can buy a modem anywhere and connect it to any buck. And the idea is to be able to do this in the future between a digital processing platform and a future digital transceiver. It has to be simple, it has to be open and available for everyone. What's quite convenient and has facilitated the development is that it's based on the foundations of Vita 49. what I think there'll be at some stage the ability to certify that, so it has to be some certification body as well, and it's all under the umbrella of the IEEE, which makes it gives it the quality stamp of being a standard. Okay, now where does this actually take place, all of this digital processing? So let's go back a little bit and see what was the first application, satellite-rated application, that was actually running in the cloud, and it was actually for Earth observation. Now, on Earth observations, it made a lot of sense, because if you think about it, you have a satellite that passes over a gateway, a ground station, and you have maybe 10 minutes of sight of the satellite. But once the satellite has passed over that gateway, it's idling and waiting for the next time for the satellite to come around. So if you have multiple gateways scattered around different places on Earth, and they each have a different schedule for downloading the information from the satellite. So if you have one single central place for doing the processing, you can save on the cost of your gateway. So it makes a great deal of sense. And if you look at the typical bit rates that are downloaded, say it's in the tens of megabits per second, maybe in the low hundreds of megabits per second. Now, the SATCOM applications that we're looking at today, especially for very high throughput satellites or NGSO constellations, we're looking at feeder lengths of 5 gigahertz per second, right? Typically, it's Ka, 2.5 gigahertz per polarization. In the future, it's going to be even more. Okay, when we're looking at support of QV, so it can be Ka and QV can add another 5, 6, 7 gigahertz. Okay, so we're looking at much wider links. For SATCOM, normally it's continuous coverage. Okay, so every gateway is active all the time. May it be NGSO or GEO, you have always the gateways active. And we're looking at extremely high speeds, okay? Because if you take just the 5 gigahertz, okay? And so going from gigahertz to samples, okay? So the whole idea of digital interfaces, you're taking analog signal and you're sampling it, and then you're encapsulating these samples into, based on the DIFI format. But in the end of the day, it's sort of like an Ethernet packet. So you're looking at a factor of roughly x30, x50 from going from gigahertz to gigabits per second, okay? Because you've got the number of samples per symbol, and you've got the number of bits per sample. Okay, so this brings you into the low hundreds of gigabits per second, which is extremely expensive and complex for backhauling from a gateway to some centralized data center. So Paul mentioned in the introduction about edge processing. This is a classic application for doing what's called edge processing. You know, we call it here on-premise. Basically, the idea is having these servers on-premise. May it be a private cloud where that's pretty trivial, but even the public cloud providers, they have the service where they can put on-premise the processing units at the gateway itself. Okay, now just give you more insights on the different aspects. So, in terms of the platform for signal processing, so FPGA has been the leading solution to date for doing the signal processing. Okay, if you look now at the evolution within the cloud, you can see that the public cloud vendors are adopting more solutions. And I think, if I'm not mistaken, it's maybe been already 5 or 6 years since Azure have been using FPGA as well. There's some very interesting clips you can see on YouTube. And an example for a leading application that's running FPGA today is AI. Okay, so in terms of the most efficient platform for doing signal processing, FPGA seems to be the leading solution today. Having said that, running in the cloud, the FPGA is not as dynamic as the CPU-based technology. Okay, so when you leasing CPU-based processing power in the cloud, you indeed can lease the granularity of leasing the resources is extremely fine, and you can ramp up and ramp down service very quickly. In FPGA, it doesn't exactly work like that, because the processing power of every card today, at least, is quite high, and you cannot share the card between different vendors. So basically, when you're committing to use FPGA resources, you're taking a whole blade in the public cloud. And also the rate of technology refresh of FPGA in the cloud is not as fast maybe as CPU. And we can just give you an example that, let's say, the multi-channel receiver that Gilat has today and we're deploying today is based on newer technology than what we can find in the cloud. So again, this is, when we're talking about the KPIs and trade-offs, so these are like give you a sort of insight of different elements and the difficult and how you have to ideal fit a solution according to the application. The overall capex becomes more expensive. This is very relevant for private cloud, but also something that to understand the economics of the public cloud. Okay, and the question is who is paying and how you're paying. Okay, if you take the functionality of a modem that you have today, so basically you're coming in with IP, okay, and you're going out an RF on the other end. Okay, now you're taking that functionality and it's being segregated. Okay, so you're taking the signal processing and running it on one of these custom off-the-shelf platforms, and you're outputting at very high speed on the DIFI, kind of like on the Ethernet port. You're outputting the samples. Okay, these samples are then going to switches, right? Because you want to decide how to route that to the different transceivers. And these switches are also extremely expensive, routing tens to hundreds of gigabits per second. And then at the other end, you've got the transceivers, okay, and they're digital now. So whereas in the past they had a simple L-band interface, you've got an expensive NIC, okay, and you've got the FPGA doing the processing, doing the DIFI decapsulation or encapsulation, and you have the A2Ds and DACs inside. So all in all, the capex works out more expensive. Now looking at the OpEx model, okay, this is going back again more to the public cloud. So now you're splitting you have to accumulate the different costs. Okay, so you have the IP you're licensing from the VSAT vendors, and you've got specific IP you're licensing from the cloud provider. I mean, let's say security services and things like that, and you're leasing the compute resources themselves. And then you have the unknown pricing updates, okay? Because I mean, even here at Gilat, where we have some platforms running on, like IT platforms running on the public cloud, we've seen prices going up quite dramatically over the last few years. So I can tell you that CFOs in the companies won't be all that keen, but again, it gives you another view, another perspective on the total cost of ownership of migrating to the cloud. So what are we doing here at Gilat? So we are working on the migration of our platform to custom off-the-shelf hardware. We're looking at different platforms. We for sure will be committed to both private cloud and public cloud, because not all customers want the public cloud. We are engaging with the customers to make sure that our roadmap is converging in terms of the performance, in terms of the timeline. We're talking a lot to the public cloud providers, okay, so that we'll be familiar with that environment as well and make sure that we have a smooth and efficient migration. We recognize that there's going to be more than one solution. Okay, we won't have one solution that fits all. Whereas if you're going a few slides back, looking at that chassis, which we provide to all our customers, in the future, it looks like we'll have to have an array of solutions. And because we will always have customers running that legacy solution, because it doesn't suit everyone to go for this cloud, maybe public or private, we'll have to try and see where we can have commonality so that we'll have efficient research and development, reusing as much as we can between the platforms. So my time is up, and I hope that was useful for everyone. Thank you very much.
Okay, excuse me. Thanks, Dubi. Now, first, I've got a couple of questions here, but I want to ask the panelists if they have any questions for you. And please keep this as a consistent theme throughout the program. If you have any questions for any of the other speakers, please just put your hand up and I'll bring you in. But in the meantime, let me kick off. In your presentation, you've been focused pretty much on virtualization of the gateway equipment and migration to the cloud. Could you perhaps say a couple of words regarding remote modem virtualization?
Sure, so that's an interesting topic. So I think that the pioneers have been the defense segment in the US. There's for sure there's a need to have like a universal platform where they can run away from some different vendors. And this is very attractive for some of our customers as well. Because you take, for example, the in-flight connectivity service. Okay, so if you have an aircraft that's under coverage of a certain satellite with a certain vendor, and now it's moving over to another satellite or another operator even with a service of a different vendor, you want to have the ability to run that IP there. Okay, the IP of a different vendor. So it's, and the same with cruise ships and other applications. So it's extremely attractive for the vendors. It's also the virtualization also offers the attractivity of being more versatile and more future looking. Where it gets a little bit complicated, and it depends again on the market, is that first of all the cost goes up, because today on most of the modems you take advantage of available ASICs that brings down the cost. So again, if it's a platform that's less sensitive to the cost, so that maybe goes out the window. But there's another aspect, which is the power consumption. At the end of the day, all these satellites are transmitting pretty wide signals. And even if the actual bit rate that's processed by a single modem is relatively low, still you have to process the full wideband carrier. And this is very hungry on power if you're doing it with a software-defined radio. So it's there for sure. There are platforms and markets where it's relevant. For other, for some applications, simply the cost and the power consumption is going to be a limiting factor.
Mm-hmm. Okay, and I came back to the first slide. Hang on, I think, yes. Just bear with me. And you related to the fact that we're currently in a new era of space, and one of the hottest topics these days are 5G NTN, non-terrestrial networks. Now, what is your view regarding 5G NTN being adopted within the VSAT networks that operate today primarily over GEO?
Okay, so no doubt, I mean, 3GPP NTN is here. Okay, so we're all following the press releases about one every few days about a new alliance between a cell phone vendor, a chip vendor, a satellite operator, satellite manufacturers. So and it's happening today based on release 17. It's happening today mainly for emergency texting. We can see a massive potential for IoT, and this is what's supported right now under release 17, which is also for the lower frequency band. It starts getting interesting in release 18, which is the first release which will really be relative and can be considered to be adopted for, let's say, GEO satellites. It's going to be addressing the VSAT configuration. It's going to be addressing the high frequency band. It's going to be addressing what's called eSIM, which is mobile terminals. Mm-hmm. And the discussions are only at early days. So, you know, assuming that most of it will be adopted, it will become, I think, one of the exciting solutions, because it's going to offer, you know, if looking at our customers, the satellite operators, they're interested in interoperability. Okay, so they can buy modems from any vendor and know that it's going to work with their hubs. There could be a potential for reducing cost if, again, everything would. At the end of the day, you've got the chip vendors, okay, and if you can have a modem based on a chip and an ASIC, the cost is going to be low. And this is yet to be seen what the chip vendors will actually adopt. So they adopted the modifications of release 17. Will they adopt all the proposed changes in release 18 to make it compatible with VSAT? Is yet to be seen. So and there's another aspect, which is at the end of the day the efficiency, because the 5G NTN has really stemmed from the 5G terrestrial networks. And there's a lot of caution is being taken not to break too far away from the terrestrial network solution, mm-hmm. which means that because it hasn't been optimized for SATCOM, which is actually the dream for 6G. In 6G, things might be different. So we suspect, and we're analyzing this, that some aspects will be less efficient than what's offered in the typical SATCOM systems that are available today. So for some cases where there'll be specific satellites or satellite operators where, for example, efficiency will be the leading consideration, what technology to select. So we might see for some cases that, let's say, the classical DVB-based solutions will be preferred. And in other cases where the leading consideration will be, let's say, interoperability, so it may well be that despite the fact that the efficiency will be lower, that they will select that. So it's yet to be seen. But again, as I said, the big event is Release 18 and the adoption of the technology.
Okay. All right, good. Now, like I say, the other panelists, if you've got any questions for Dubi, please speak up. There are some coming in actually via the questions box and the chat box. And in fact, there are around about 170 people involved that are actually connected to the chat box at the moment. So please, you know, speak up, get some dialogue going, get the best out of it that you possibly can. There's around about 1,000 people in the room. So I would like to see more of you actually getting involved in the chat box and really stimulating some conversation here. Now, Dubi, thanks very much for that. Appreciate it. And I'll leave you to answer the questions that are coming in for you via